For number 1, you are going to spin on the first spinner, and then spin on the second spinner, and then take their product. So for example, if you spun and you got a 1 the first time, and then you spun on the second spinner and you got a 4, in your table it would look like this. You would get a 1 the first roll, a 4 the second roll, and their product would be 1 times 4, which is 4. Then the second time, maybe you got a 2 and a 5. Well, 2 times 5 is 10. So you're going to go through and you're going to do that, I believe it's 15 times. You're going to repeat that process. Then you're going to count up the last column and you're going to see how many times you got 8 or less. And for A, you're going to write how many times you got 8 or less out of the 15 times you did the experiment. For B, you're going to figure out how many times you had more than 8. So anytime the product was more than 8, like 10, for example, is more than 8, you're going to put that number on top out of 15, because that's how many times you did the experiment. For C, you're going to count up how many times you got 8 exactly, and put that one out of 15. D says what was the most likely product in the game. So whatever number you got in the very last row, which one happened the most? Did you get an 8 the most often? Maybe it was a 10 or a 12. What number showed up most often in that last row? For E, it says if you play this game another 15 times, are you going to get exactly the same results? Well, probably not. Because even if our values are similar, we're not going to get them in the exact same order. No, because this is an experiment, and it's random. A random experiment. So we will get similar results, but they're probably not going to be identical. That would be pretty crazy. The probability of that happening is very small. In number 2, it says a 7th grade student surveyed students at her school, and she asked them to name her favorite pets. Then we have a bar graph to show the results of that survey. It says how many students answered the survey question. Well, we know that 9 said dogs, 6 responded with cats, 4 liked turtles, 5 said snakes. Ooh, snakes. Those are not my favorite. 5 said fish. And 2 said gerbil. Okay, so altogether, we're going to add up to figure out the total. You might even notice that you can group some of these numbers to form tens. 10, 20, 29, 30, 31. So A says, how many students were surveyed? 31 students were surveyed. B says, how many said snakes was their favorite? Well, right here we said 5 liked snakes. So it says, what is the estimate for the probability of a student saying a dog is the favorite? Well, 9 said dogs, and 31 students were surveyed, so our probability is 9 out of 31. If you change that to a percent, you can do the cross multiply and divide technique to figure out what percent it is. In D, it says to estimate the probability of saying a gerbil. Well, 2 people said gerbils, and you can set up the same strategy to figure out that percent. In E, it says, what is your estimate for the probability that the students would say frog? Well, did anyone in our survey say frog? No, so we should have 0 out of 31 students said frog. And if we were to write that as a percent, how much percent would it be? So go ahead and finish these. Spin with your paper clips, find the products, answer the rest of these questions by finding the percents, and don't forget your name.